Welcome to 7.RP.3 Goal 1. So in this goal, you are going to be focusing on using proportions to solve multi-step ratio problems. And this is specifically section 6.9. And in this section, we will be dealing with what's called indirect measurement. So essentially, we will be looking at problems that we're going to have to create proportions with. There are going to be word problems, and we're just going to have to understand all the various steps that we may need to take to solve these problems. So to start out with, what is indirect measurement? Well, indirect measurement, it allows you to use the concept of similar figures, perhaps triangles, squares, that sort of thing, but you'll usually see triangles, to find an unknown or difficult to find measurement. So in this case, we have two triangles that I've drawn. We have one that we don't know how tall it is, but we know it's 16 units across, and we have a smaller triangle that is 2 units across and is 3.5 units tall. So what we can do here is we can set ourselves up a proportion, and our proportions will look something like this. We will have 16 perhaps on the bottom, and that is related to 2 on the smaller triangle. So if you notice, we have essentially the short side being compared on one side, and then we don't know how tall the triangle is, but we know how tall the other triangle is, and it's 3.5. So now we have the tall side. As well, we can notice that we are looking at the big triangle and the little triangle. So we have created ourselves proportions, and we know how to solve something like this. We've done this in the past. Essentially, we can either find scale factors, so how many times does 2 go into 16, or how many times is 16 divided by 2, and find the scale factor. And if we do that, we can see that we're dividing by 8, so that means if we're going to go to the other direction, we need to multiply by 8. We can do the same thing here, multiply by 8, so 3.5 multiplied by 8 is 3.5 multiplied by 8 is essentially where x is equal to 28. As well, we can do this in a different way. We can actually still have our proportion. X is to 3.5 as 16 is to 2, and we can set up our proportions like this. And essentially, we would multiply 16 times 3.5 and have that equal to x times 2. And 16 times 3.5 is 56, and that is equal to x times 2, and we divide that by 2, and we'd have x is equal to 28. So we get the same thing. We get 28 units for the height of a triangle, but we can do it in 2 different ways. We can use scale factor, or we can use cross products. So scale factor is this one, and cross products is this second situation. So now let's take this concept and apply it to a real life scenario. So we have people going on the D.C. trip here soon. So the lead statue at the Korean War Memorial in Washington, D.C. casts a shadow that is 43.5 inches. At the same time, a nearby tourist casts a 32-inch shadow. If the tourist is 64 inches tall, how tall is the statue is what it's supposed to say. So I screwed up there. This should say statue. Sorry, so how tall is the statue? So let's actually create a couple of similar triangles. So we have this tourist guy. He stands there, and actually I'm going to use a slightly thicker pen. So we have this tourist guy. He stands there, and he is 64 inches tall. And he casts a shadow that is 32 inches long. As well, we have this War Memorial statue, and we don't know how tall that is, but we do know his shadow, the statue shadow. It casts a shadow that is 43.5 inches long. So we can set up our proportion here. We can compare the height of the tourist to that of the statue, which we do not know. And I'm actually, instead of doing a question mark, I'm going to call this X. So the statue being X inches tall. And we are going to compare that to the shadows of both of these objects. So the shadow of the tourist is 32 inches, and the shadow of the statue is 43.5 inches. So now we can either do cross products, or we can find a scale factor. So we could figure out a scale factor to go from 32 to 43.5. So we divide 43.5 by 32, and we'd have a number that we'd be able to multiply those two numbers by. And that's a little messy. That's getting messy. So I don't actually want to do that. Instead, I'll do cross products. And while that is still messy, it's a little bit easier to deal with. So we would have 64 times 43.5, and that is equal to 32 times X. So 64 times 43.5, if we did that math, we have 2,784 inches, and that is compared to 32x. X. Last little bit, we need to divide by 32, and essentially 2784. That simplifies down to, divided by 32 is simplified down to 87 inches. So the height of the statue is 87 inches. It is a solid 27 inches taller than me, which if I were to figure that out, ends up being a little bit more than 2 feet taller than me, 2 feet 4 or 2 feet 3 inches. I'm so short. Anyways, let's go on to another real life scenario. So here's a missing measurement. We have a guy that's hanging out on the side of a pond, and he wants to figure out how wide the pond is in its widest or almost widest location. Maybe you can't see it because of that extra little tree that's like right there. But this guy is standing there next to this tree, and he's trying to figure out how wide this pond is. And he knows a few measurements from where he is standing. It is 138 feet to this point from where he's standing. It's 138 feet to a perpendicular point from that widest area. And then it's also 46 feet to a tree just behind him. And between those two trees, there is another and between from that tree to another tree, it is 60 meters. And actually, he figured out that this 60 meters by 46 meter triangle, this particular triangle, is proportional to this larger triangle. And if that is the case, we can create ourselves a nice little proportion. We essentially can say, well, the corresponding side 46 is to the side 138. In the same way that 60 is to this other missing side, X, right here. Essentially, if we actually looked and saw how we set up this proportion, we can see this is the small triangle. This is the large triangle. We have on this side, we have one side being compared, and we have another side being compared. So we can see that essentially we can create a nice little proportion out of all of this. So let's actually do the math here. We'll do it in a little bit of pink, or pink and purple. So if I have 138 times 60, that is equal to 46 times X. So a little bit of math here. 138 times 60 gets us 8,280, and that is equal to 46x. We're going to then divide by 46, and we get 180 meters is that missing width of the pond. So that width right there is 180 meters. So that pond is pretty darn wide. If we thought about that in feet, that is 540 feet across. So that's pretty big. It's almost as big as 2 football fields. So hopefully this helps you do these following problems. You're going to be doing problems 314 on page 314, number 1 through 7, and you're going to do all of them. or you're going to do 8 through 14, all of them. If you don't get proficiency on those set of problems, then you need to do both assignments and check them both in the binder in the back of the room in the purple binder. Good luck with your homework. If you have any questions, as always, you're not alone. Please ask. I will be happy to answer anything you may have. Thank you so much. Bye.